Hello, this is Mr. Win, and this video is about properties of logarithms. So in the previous video, you learned how to convert from log form to exponential form and vice versa. That technique is used at the end when finishing problems. Usually the problems look more complicated and have multiple terms, so in that case we'll do the 3 log properties to help us simplify the problems and combine the terms. Now before I go into the 3 properties, let me introduce one more log. You already know that all logs must have a base. For example, log base 2 of x and log base 35 of 9. Remember, the base is missing, it's automatically a 10, so log of 90 is really log base 10 of 90. The base can even be pi, which is about 3.14159, or e, which is about 2.718. And if you don't know what e is actually the natural number. It appears all the time in nature, in the real world. But anyways, e is special and gets a shortcut abbreviation when we use log base e. So while you can technically write log base e of something, you should actually write ln base e of something. And in fact, ln is used exclusively for e, so you don't have to put the e there. So that means if you don't see a base for ln, it is always an e by default. Again, ln is still a log, so the converting technique and the 3 properties will also apply. So the first property is the power property of logarithms. Whenever you have the log of something that has an exponent, you can bring down the exponent to the front as a multiplier. So for example, if we have log base 8 of 15 squared, this exponent of 2 can be moved down to the front as a multiplier until we get the final answer of 2 times log base 8 of 15. So let me show you that in a calculator. So remember, you go in math, and go up to log base 8 of 15 squared gets us this decimal. I'm going to do 2 times log base 8 of 15 for the exact same number. And it matches. Alright, this formula does work the other way around. So we could move this multiplier 2 back up to the top to make it a log base 8 of 15 squared. Usually won't do that unless we're solving. One other thing to note is if you have a number and exponent, you should actually fix that. So I could also do log base 8. 15 times 15 is 225. So all 3 of these are the exact same thing. Alright, but to use the property, just move the exponent down to the front. Alright, this one, ln base e of 7 cubed. All we do is move the exponent of 3 down to the front as a multiplier. So our final answer is 3 times ln of 7. So let's check. Ln is actually this button right here underneath log. Again, there's no x base, so you just leave it alone. 7 to the 3rd power gets us this number. If I do 3 times ln of, and it's not log, it's ln of 7, I get the same number. Now also I told you ln is log base e, so let me show you that. If I do 3 math up at log base e, e is actually second in divide of 7 is the exact same thing. Alright, so again, ln is just log base e, but we use ln to have less writing, it's abbreviation. Alright, the product property of logs is whenever you have multiple terms of the same base, and it has to have the same base being added, you can combine them into one log using multiplication. Now just remember that exponents and logs are inverse of the opposite. So when we used to multiply like x squared times x to the 5th, when you multiply letters you add the exponents. Here we're in the reverse. When we're adding basically the exponents, we're going to multiply. Alright, so rewrite log base 5 of 3 plus log base 5 of 6. These are both log base 5, so I come down to a single log base 5. Now I'm going to multiply the inside, 3 times 6. So 3 times 6 is 18. So let me check that in the calculator. Math up, log base 5 of 3 plus math up, log base 5 of 6 gives me this answer. If I do a single log base 5 of 18, it's the exact same decimal. Now, we will usually combine it, but if you want to reverse it and go backwards, if you want to split up to multiple logs being added, you could do that. So what else multiplies 18? Maybe 2 and 9. So I could actually say, go back to the calculator, I could do log base 5 of 2 plus log base 5 of 9, because 2 times 9 is also 18. Same decimal. Alright, ln question. ln of 4 plus ln of 10, they're both the same log base e. So I can make a single logarithm, single ln, and I just multiply the insides. 4 times 10 to get the final answer, 40. ln of 40. So ln of 4 plus ln of 10 gets me this decimal. If I do ln of 40, it should be the exact same decimal. Alright, so basically we're learning to combine like terms in a sense. Alright, the last property is the quotient property. Whenever you have multiple logs of the same base being subtracted, you can combine with a single log using division. Again, only divide the insides, the base stays the same. And as always, this property, your formula works backwards as well, if you want to split it up to multiple logs being subtracted, but usually you don't never do that. So log, the base is missing, so it's 10. So log base 10 of 20 minus log base 10 of 5. So they're both the same log base 10, so we make it a single log base 10, and we divide the inside to 20 divided by 5. So 20 by 5 is 4. So let's check that in the calculator. Now, I could do log base 10 where I go to math, up, and doing log base 10 of whatever. So say 20 here, minus math, up, log base 10 of 5, and I get my answer. I'm going to introduce you this button above ln. This is log right here, but this is log base 10 only. I can't make a base. So if I press this, log, it doesn't let me enter a base. Again, it's invisible, so it's automatically 10. You cannot use this button if you're doing like a log of a different base. But log 20 minus log 5 should be the same decimal. And we said it turns into log 4. So log base 10 of 4 is the exact same decimal. And again, we could also go backwards. What divided what could give you 4? Maybe 100 divided by 25. So let's try that. Log of 100 minus log of 25 should get us the same decimal. There you go. Alright, last problem. ln, and they gave us base e this time, but it's always the e for ln. But anyways, ln of 80 minus ln of 10. They're both the same log base e. I can make a single log base e, divide the insides, 80 by 10. Well, that's 8. So let's check this. ln of 80, not log 80, ln of 80. Actually, let me show you real fast. Log of 80 and ln of 80 are two different things because they have two different bases. Alright, so the base is very important. So notice these are two different numbers. Alright, so anyways, we're doing ln of 80 minus ln of 10 gives us this decimal, and then ln of 8 should be the exact same thing. It is. Alright, so that's the whole video. Hope you enjoyed it. Make sure you ask your teacher any questions. Thanks for watching. Bye.